Questions 28 and 29 are coin and ticket problems. Let's take a look at that first one here. So it talks about a jar of dimes and quarters containing $15.25 worth of coins. And so when we have 103 coins in all, we're setting up a quantity and a value equation. So let's write that down. We've got our quantity equation, and the quantity equation is how many coins we actually have. So we have a total of 103 coins, but we have two different types. We've got dimes and we've got quarters. And since they want to know how many of each type there are, we're going to use D for dimes, Q for quarters. That's what we're going to set our variables equal to. So our variables are always going to be whatever the question is of. And here we don't know the number of dimes, don't know the number of quarters, but we know there's 103. So if we add up the number of dimes and the number of quarters, it'll equal 103 coins. Now we look at the value. The value of a dime is 10 cents times the number of dimes. 25 cents for the number of quarters, for the value of the quarters. And since I'm in cents, notice that's 10 cents, 25 cents, I need to have the value, this $15.25. I need this in cents. So I'm going to change it to 1,525 cents. Now if I wanted to leave it in dollars, I'd have to put 0.10D and then 0.25 Q. But it's easy enough just to leave it without the decimal, so that's why I changed it. So I'm going to go ahead and multiply this top equation by -10. Every single number there by -10. The common mistake is people will forget to multiply the 103 by the -10. So I'll go ahead and do that. I've got -1030, and I'm adding this together, and I get these D's to cancel. And when I go ahead and combine, I subtract, and I get 15Q. On this side, got to do a little borrowing once I get to the second digit here, and that ends up giving me 495. So from that point, we'll just do a division problem here. Divide 15 into this number, and let's see what we get. So if we do 495 divided by 15, that gives us 33. So there's 33 quarters, and so to find the number of dimes, you're just going to take that 33 and substitute in for Q. Well, basically all you're going to be doing is subtracting it from the total, so I'll go ahead and do that. 103 minus 33 gives me 70, so that's 70 dimes and 33 quarters. So that's the same way we're going to do this problem. The only difference is we have different units. We do have quarters, which is the same, but now we have nickels. So we're going to set up our quantity equation. So I'll just use Q for quantity there. And actually, I'll go ahead and spell it out since we've got the Q for quarters there. So Q plus N equals the total number of coins, 13 in all. And now we'll set up our value equation. So the value is going to be the value of the coins. So 25 cents for the quarters, 5 cents for the nickels. And we go ahead and check out all the value in cents. Make sure you change this to cents, though. It's going to be 125 cents. So before we can just add the equations together, we need to cancel something out. So I'm going to go ahead and multiply this by -5. Every number there by -5. So -5Q minus 5N equals -65. So I go ahead and add this stuff together, and I get those N's to cancel. I'm left with 20Q. Do the subtraction here, we end up with 60. So when I do that division, it does end up going in there evenly. And you see you can cancel out these zeros, so we're just left with 2 into 6 goes 3 times. So there are 3 quarters. Find the number of nickels, just subtract it from the total. So there's 13 total coins. Subtract the 3 and you've got 10 nickels. So 10 nickels. Well, this last problem is an admission or a ticket problem. And so it's pretty much the same sort of thing. We have a quantity equation, and we're also going to end up with a value equation. So let's take a look at it. There's 429 people. That's like the total number of coins in the last problem. There's adults, and they cost $1, 75 cents for children. Total receipts, like the total value, is $372.50. How many adults and children ended up showing up? So we have A for adults, C for children. So we'll go A plus C equals the total number, 429. And so then we have to come up with a value. And so the value is going to be the value of an adult ticket. $1 for an adult ticket, 75 cents for a children's ticket, and the total value was $372.50. Now notice, the last few problems I've been changing them to cents. Now in this problem, I'm going to leave it as dollars, because if I change it to cents, I'd have to move that decimal 2 spaces, and the numbers just get really large. So I think it might be easier just to leave it as cents, or leave it as dollars. So what we need to do is multiply this top equation by -1. And that'll cancel out the a terms. So negative a plus, or negative 1a, actually minus now, so let's go ahead and fix that. So we've got minus 1c equals, and it's going to be negative 429. Now off to the side, we'll need to do 429 minus 372. And notice that there's a decimal point and a 5, so I'm going to add the decimal point next to the 429. You have to borrow from the 9, change it to an 8, and also borrow from the 4, change it to a 3, and then do the subtraction. So we've got 5, and this makes 6, and a 5. So 5.25c, and that's negative because I subtracted 1 from 75 cents, is 0.25 cents, 56.50. And so now that's negative as well. So when you do the division, divide by the 0.25, you got to move the decimal. Here's where you have to move the decimal 2 spaces over. So really when you do this, you're actually going to end up doing 25 into 56.50. Well, 25 into 56 just goes 2 times, makes 6 left over, so it goes into 65 there another 2 times, makes 50 once more, and we have a 1, a 5, and a 0. Well, 25 goes in 156 times, so there it is, C equals 226. Just subtract that from the total, do it off over here since I'm running out of room, 429 minus 226, do that subtraction, we get 3, 0, and a 2. So that's the number of adults, this is the number of children. Well, the next few problems ask us just to multiply binomials. So we're using that FOIL method, the first, outer, inner, last. So here are the first terms, x and x make x squared. Outside terms, negative 4x. Inside, negative 2x. And the outside, the last terms, they're positive 8. Watch the signs. 2 negatives make a positive. So we can go ahead and collect the like terms we see here. So these 2 terms right here will combine together as 1 to make negative 6x, but you got to bring everything else down. So x squared minus 6x plus 8 is the answer. Over here, the first terms make a 6x squared. Common mistake is people forget the squared symbol, so make sure you get that. Outside are 2x, inside are 9x, and the last terms make 3. Go ahead and collect some like terms there, and you just bring everything else down that can't combine. So we got the 6x squared, a plus 11x, and a plus 3. Next one, 5x and x make a 5x squared. Outside terms are a 40x. Inside make a negative 2x, and the last terms make negative 16. Go ahead and collect some like terms. Outside and the inside collect together, you get 5x squared plus 38x minus 16. Well, the next one here, we have 2x and 3x make another 6x squared. Seen that before. 2x and negative 2 make a negative 4x. Inside are 3 and 3 make 9x. And the last terms, 3 and negative 2 make negative 6. So we can collect these inner and outer terms. So what's left over, bring down that 6x squared. Got a positive 5x and a negative 6. Well, the last ones here, x and x make an x squared. X and 2 make 2x. 8 and x make 8x. And 8 and 2 multiply to make 16. Collect the like terms there. Outside and inside terms, add to make 10x. So you just bring down your x squared plus 10x plus 16. And that is our answer. Well, the next few problems are exponent rules. So let's take a look at those. So first one there, we've got to reduce the fraction. Common mistake is people want to subtract the coefficients, but that's not what we do. We're dividing by 5, the top and the bottom. So this becomes 3. This becomes 1. So let's rewrite that. 1 over 3. Leave some room for some x's to see what's left over. Notice that this 1x here will take away 1x from the top, leaving us with 3 x's. So x to the third over 3 would be your answer. Looking at the next one there, same sort of thing. So 6 goes into the 12 2 times. So far we've got 1 over 2. And so from that point we can go ahead and cancel out some x's. Well, now the x's, there's more x's on the bottom of the fraction. So when you take away those 6 x's from the top and from the bottom, you're left with 2 x's on the bottom. So common mistake is people want to say just 2x squared, but that's wrong. It's got to be 1 over 2x squared. Next one here, 3 goes into this 9 3 times. X squared goes into the x to the fourth just 2 times. So we've got 3x to the second. So this one you can just write as 3x squared. Notice how everything's on top. That's why you'd write it that way. Common factor between the 18 and 27 is 9. Do some reducing. So 9 goes into 27 3 times. 9 goes into the 18 just 2 times. So rewrite those numbers, 2 and 3. Leave some room for the x's to see where they're at. These 2 x's will cancel out 2 from down below, leaving us with 3 x's on the bottom. So 2 over 3x to the third. Last one here, 14 and 28 have a big factor of 14. So 14 goes into 28 2 times, and 14 goes into 14 once. So we rewrite those numbers as a fraction, again leaving some room for the x's. And notice the 3 x's are canceling 3 x's on the bottom. So remember, subtract the exponents, because you're counting up how many exponents are being multiplied. And when we're dividing, we cancel out some common exponents, so we're left with 6 x's on the bottom. So 1 over 2x to the 6th. So those are some of the problems. Check out other parts for other problems.